when you're looking at the unit circle and in your bell work they said 120 degrees, you would have wanted to graph that, which we're going to do, and look at your SOHCAHTOA, which is created from a unit circle. All right. So when you have angles, what happens in the unit circle is you start having angles that are more and more common. And if you look, they kind of give you an example. Your radius of a unit circle is always 1. Always 1, which means you automatically know some x's and y's here. If my radius is 1, then over here, this is actually 0 degrees. My coordinates should be 1, 0, right? Because I've gone 1 unit away from the center and I haven't moved up or down. So 1, 0. Here, I'm at what degrees? 90 degrees, right? 90 degrees. I know this one as well, 0, 1. I've gone up 1 unit and I haven't moved left or right. And then if I come all the way over here, I'm at 180 degrees, right? And I know this one. I've gone 1 unit left and not up and down, so that's negative 1, 0. Down here is 270. I've gone down 1 unit and not left or right, so it's 0, negative 1. And so those 4 are very easy to see because those are angles that fall on an axis, right? 0, 90, 180, 270, and then 360 is the same as 0, okay? So those are simple. What starts happening when you go within those from 0 to 90, from 90, when you start falling on a quadrant, is you have to then calculate it based on SOHCAHTOA. And so you start developing certain angles that appear over and over and over. And so what we're going to do is we're going to go over those common angles. And we're going to first show why they happen. And then we're going to start filling in the unit circle so that you can start seeing the pattern as to why the unit circle does what it does. And so the one that they gave us, for example, was 120. So let's look at 120 on the bell work, right? They wanted us to find out what the coordinates would be for 120. All right, so that's what we're going to do first. We're going to do our axis here. All right, and so 120 degrees, let's think about where that would be. All right, remember we always start at the x-axis here. So that's the beginning side there. And now we need to figure out what the terminal side is. Well, 120 degrees, this far would be 90, right? And how much further do I want to go from 90 if I want to get to 120?
30.
Another 30, right? So I should be about right here maybe. Okay, not perfect, but we're just sketching it.
Perfect window.
Yeah, well, it kind of.
It's kind of a tool.
All right, so if we say that is 120 degrees, how much is going to be left over from 120 down to 180?
60.
That's going to be 60,
Wow.
right? And so if I drew then this right triangle here, okay, and actually let's do it a little bit closer in because we have like a unit circle going on. So let's say I do this, right? If I do that right triangle, then I have a 60-degree angle here. This is a special right triangle. This is a 30, 60, 90 right triangle. This is my short side. Yes?
Mm-hmm.
My long side is the side times the square root of 3. And my radius of a unit circle is always double my short side, right? 2s, okay? And of a 30, 60, 90, this is how it works, all right? They want to know then, they're trying to say, what's the xy? Well, then I need to know the y is going to be my long side, right? And the x is going to be my short side. So this point right here is going to be xy because I've gone left a certain number of digits and I've gone up a certain number of digits to get to that point, correct? All right. So if I want to know my y value then, I can use SOHCAHTOA with this 60 degrees, right? How can I use SOHCAHTOA? I can say, well, opposite over hypotenuse, right? Mm-hmm. So my y value is my sine, we already know that, which is opposite over hypotenuse. What is my opposite side from my 60?
S squared of 3.
S squared of 3. What is my hypotenuse?
2s.
2s. It reduces to
Square root of 3.
Square root of 3 over 2. So my y value is going to be the square root of 3 over 2. I can write it correctly. All right, that's my y value. Yes?
Yeah.
My x value, well, my x value is my cosine, right? SOHCAHTOA once again. So my x value is my cosine, which is adjacent over hypotenuse, SOHCAHTOA. My adjacent side is just s. My hypotenuse is 2s. That reduces to 1/2. That means my x value is 1/2. However, what quadrant am I in?
Negative.
Correct. I am in the second quadrant, which means my x value is negative. So that means that is negative 1/2 and square root of 3 over 2. So if I said, well, what is the sine then of a 120-degree angle? You would just give me the y value. What's the y value there? Square root of 3 over 2. If I said, what is the cosine of a 120-degree angle? You would say negative 1/2. And if you take your calculator and you take the sine of a 120-degree angle, it's going to give you this crazy decimal. If you take the square root of 3 divided by 2, it's going to give you the same crazy decimal. So if you go in and you say sine of 120, assuming you're in degrees, right? And if you say the square root of 3 divided by 2, you will get the same, and make sure you're in degrees, by the way. If you get a weird answer, you're not in degrees. But if you do the sine of 120 and the square root of 3 divided by 2, you should get 0.866. Does everybody get 0.866?
Yes.
That's what should happen. It is just giving you the ratio. And so that is how we build the unit circle. We build the unit circle with SOHCAHTOA. We build it with these 30, 60, 90 triangles. And then we also do it with 45, 45, 90 triangles. And so your common angles on your unit circle are built from either a 30, 60, 90 triangle or a 45, 45, 90 triangle. This is just where it's a place for you to fill in. On the unit circle, cosine theta, sine theta is your x, y. So when I ask for cosine from the unit circle, I'm asking for the x value. When I ask for sine value on the unit circle, I'm asking for the y value. It is the ratio between the opposite and hypotenuse or the adjacent and hypotenuse. And I want to be clear that the unit circle is what helps us come up with these ratios, but the size of the angle does not matter. And what I mean by that is the triangle that's created. So if I have the cosine of 120 degrees we'll go with sine of 30, that's easier. The sine of a 30-degree angle is 1/2, all right? Whether it is a triangle that I can draw on my paper or whether it's a triangle used by NASA to move the satellites, the ratio between the sides of a 30-degree angle is always going to be 1/2 when you compare the opposite side over the hypotenuse, all right? And so that ratio will never change as long as the degree is 30 degrees that created that triangle. The sine value, the signs here, and by this S-I-G-N-S, not S-I-N-E, all right? Signs meaning positives and negatives, all right? We've talked about the sine and cosine, the x and y values. So in the first quadrant, your x value, which is cosine, and your y value, which is sine, will both be positive. Let's talk about what tangent is, all right? So when we're talking about SOHCAHTOA, and we have a right triangle, all right? So let's look at this part right here, all right? So if we had like this 60-degree angle, let's say this is 60 degrees, okay? This is my short side, this is my long side, and this is my hypotenuse, okay? We've talked about what sine and cosine are. And because it's a unit circle, it ends up being just your x and your y value, okay? But let's talk about what happens when you have your tangent. What is tangent in SOHCAHTOA?
Opposite over adjacent.
Right. So we have sine, which is opposite over hypotenuse. And we have cosine, which is adjacent over hypotenuse. And then we have tangent, which is opposite over adjacent, all right? So what happens in this case is My hypotenuse is just 1, correct? In my unit circle, right? We've determined that the hypotenuse is just 1. So my sine is actually just my opposite side. So sine and opposite side are the same thing on the unit circle. All right? If my unit circle has a hypotenuse of 1, then my cosine is the same thing as my adjacent. So I can replace the word opposite with sine, and I can replace the word adjacent with cosine. So my tangent is literally just my sine over my cosine. My y over my x, all right? Y over x. So this is where we get these positive, negative signs for your tangent. If I am doing sine over cosine, it's going to be positive over positive in the first quadrant. So what is this value then? Positive. Let's look at quadrant 2. My y value, which is my sine, is positive. My x value, which is my cosine, is negative in the second quadrant. Tangent is sine over cosine. What happens when I put a positive over a negative? It's a negative, right? Third quadrant, my sine is negative and my cosine is negative. X and y are both negative. So I'm putting y over x, negative over negative. So my tangent in my third quadrant is positive. Fourth quadrant, my y is negative, my x is positive. Negative over positive, it is negative. And so you'll notice in the first and the third quadrant, your tangent is positive. In the second and fourth, your tangent is negative. All right. All right, so we're going to start with the 30 degrees. We're going to walk around the graph with just 30 degrees, okay? So we're going to start at 0 degrees. 0 degrees is going to be right here on the line. So that's going to be 0 degrees, okay? The first little dash that happens, that is 30 degrees, all right? And then you're going to jump over that center one and go to 60 degrees. So we have 0, 30, 60. Straight up is...
So wait, that middle one like 45 then?
Yep, we're going to get to the 45s because they do something different. 30, 60, 90, right? And then so my next dash is also 30 away. That's 120. The bottom dash there is 30 away. That's 150. And then, of course, right on the line is 180. Okay? Another 30, and we're at 210. Another 30. We're at 240. Straight down is my 270. And then in my fourth quadrant, I go to 300. 330. And then when I make my complete circle, that line also represents 360. All right, the next group of them is the 45s. So you start at 0 and we have 45, right? And we are literally going by 45s. 45 up, you get 90, which we've already written. Another 45, and we get our 135, right? And if you add 45 to that, you'd be at the 180. If you add another 45, where are you? 225, right? Another 45 gets you to the 270. And then another 45, you get 315, which you'll notice you're exactly halfway in between, right? Halfway in between all of them. All right? Now let's talk about what happens when we're talking about the sine and the cosine of a 30-degree angle or of a 45-degree angle. All right? We did this with the 30, 60, 90 triangles. So if I'm looking at a 30-degree, okay, and if I were to draw that triangle out, it would cross the x-axis right here at this dot. That is where that 30-degree would cross the x-axis. And so if I were to take this and I were to draw it straight down, which you don't necessarily have to do this, I'm just showing you what's going on for the sake of creating these x's and y's that we're about to do. Then I have a short side, a long side, and then a hypotenuse, all right? And so if I want my sine value here, I'm going to put the short side over the hypotenuse, which gives me that 1/2. And if I want my cosine, I'm going to put the long side over the hypotenuse, which gives me the square root of 3 over 2. And so this is how we're going to build the unit circle, all right? But what starts happening is there starts to be this relationship between all of these angles, all right? Every 30-degree angle has the same sine and cosine. We've already said that. And so the sine and cosine of this is 1/2 and square root of 3 over 2, right? Sine is your y value, cosine is your x value. If I look across the way at the 150 though, where from 150 down to 180, what is my angle measure? 30. It is going to create the same x and y's. This is going to be exactly the same, square root of 3 over 2 and 1/2. However, in this quadrant, one of those changes signs. The x, so that is negative. 210 up to 180. How many degrees is that?
30.
30. This guy right here is going to be the same exact values. Square root of 3 over 2, 1/2. However, in the third quadrant, what about those values? Positive or negative? Those are both negative. 330. How far away from the x-axis is 330? 30 degrees. This guy right here is the same exact value. Square root of 3 over 2, 1/2, except one of these is negative. Which one's negative?
1/2.
The y value, my sine. So there we go. Every 30 degree has the same exact values. The positive negatives just change. All right? The positives and negatives just change. Let's look at the 60 degrees. So for 60, all of a sudden, my opposite is my long side, and my adjacent is my short side. And so for a 60-degree angle, what literally happens, and we saw this when we did right-angle trigonometry, is complementary angles, angles that add up to 90, their sine and cosines just flip-flop. All right? So for a 60-degree angle, when I work out the same triangle like I did, my cosine is 1/2, and my sine is the square root of 3 over 2. Because I just drew the triangle a different way, right? I just drew it sharper, which means the opposite side is my long side, my side square root of 3. And my adjacent side is my short side, just my s, okay? And so your sine and cosines flip-flop. 30 and 60 have the same numbers, but they're flip-flopped, okay? Which means if I cross over, 120 creates a 60-degree angle down to my x-axis. So what do I know about those coordinates? They're going to be the same, except one thing changes. What changes? Yes, my x value is negative here. And then if I drop all the way down to 240, 240 is 60 away from my x-axis. That also has a 1/2, square root of 3 over 2, but both of these are negative. And if I jump over to 300, that one is also 60 degrees away from my x-axis. That is also 1/2 square root of 3 over 2. However, my y value is negative. My sine is negative for that one. Let's look at our 45s. Okay? So for 45, it's a little bit different. So for 45, and I'm going to draw it out here so that we don't have, my sides are actually the same value, right? And my hypotenuse is what? Side times square root of 2. And so if I want my sine value, my opposite side over my hypotenuse, and my cosine value, adjacent over hypotenuse, is going to be the same thing. It's going to be 1 over the square root of 2, but we're not going to leave it like that. We're going to rationalize it, right? So we end up with square root of 2 over 2. This is true for all 45-degree angles. The x and y value, the cosine and the sine, will be the square root of 2 over 2. All right? And so that means this 45-degree angle, that's the square root of 2 over 2, square root of 2 over 2. Your side lengths are the same for a 45. That means 135 is also 45 away from my x-axis. This guy is the square root of 2 over 2 and the square root of 2 over 2. However, my x value is negative. 225 is 45 away from my x-axis. That guy is square root of 2 over 2. Square root of 2 over 2. They're both negative. And then 315 is 45 away. Square root of 2 over 2. Square root of 2 over 2. And my y value is negative. Easy enough. All right, the last thing we're going to fill in is we are going to fill in our 0, 90, 180, and 270. 0. Well, the 0 moves 1 away from the center of the circle and doesn't move up or down. He is 1, 0. 90 degrees. He moves 1 up and doesn't move left or right. He is 0, 1. 180. That moves left, but not up or down. So -1, 0. And 270 moves down, but not left or right. He is 0, -1. So if I were looking at my unit circle, and I would ask you a question like, what is the sine of a 150 degree angle? What would you tell me? 1/2. Mm-hmm. If I said, what is the cosine of a 315 degree angle?
Square root of
2 over 2.
Yeah, square root of 2 over 2. So then what happens if I say, what is the sine of a -90 degree angle?
I would say
Wait,
Negative 90.
the
Zero,
sine.
-1, or 0,
So it's just your y value.
Oh,
So just -1, okay? Does everybody see how using the unit circle to get exact values of a sine or cosine, you can use the unit circle?